Alright, this is the last video for solving by factoring for trig functions. So here we got 10x plus root 3 times secant squared x minus 4 equals 0. We can ZPP immediately. So we've got 10x plus root 3 equals 0 and secant squared x minus 4 equals 0. The first equation just becomes 10x equals negative root 3. And the second equation is secant squared x equals 4. And then if we take the square root of both sides, the second equation becomes secant x equals plus or minus 2. Now we don't like secant as much as we like cosine its reciprocal. So I'm going to take the reciprocal of both sides and get cosecant x, or cosine x equals plus or minus a half. So the first equation, where does tan x equal negative root 3? Well, you should know, hopefully that happens at the pi over 3 angles. And that means these are the tall triangles. And tan is negative in quadrants 2 and quadrants 4. So those angles are 2 pi over 3 and 5 pi over 3. Now where's cosine x equal to equal to positive half? We'll do that first. So that would be a tall triangle here. So here's cosine x equal to positive a half, as well as down here. So those two angles would be pi over 3 and 5 pi over 3 again. Then we need negative a half, which means we're in these two quadrants. And so now we're going to get 2 pi over 3 and 4 pi over 3. What you may notice is we've got an overlap of answers. So when you write your final answer, you would only write them down once. So don't write down 2 pi over 3 twice, just write it once. 4 pi over 3 and 5 pi over 3. These are all answers. And what essentially happens is the answer of 2 pi over 3 makes both of these terms 0. So it makes the entire product 0, but it doesn't mean you write the answer twice. So that was number 17. Let's go on to number 18. So here's our new problem. 2 sine of x minus root 3 times 2 cosine squared x minus 1 is supposed to equal 0. So we can ZPP immediately. 2 sine x minus root 3 is equal to 0. And the other answer would be, coming from this equation, 2 cosine squared x minus 1 equals 0. The first equation, if you solve it, you get 2 sine of x equals root 3 divided by 2, and we got sine x equals root 3 over 2. The second equation, we've got 2 cosine squared x equals 1, then cosine squared x equals a half. Now when you take the square root of both sides, you're going to get cosine of x equals plus or minus the square root of a half. And so you've got to be pretty careful here when you deal with something like this, because that's not a number on the unit circle we know. So let's break this up. The square root of the top number is just regular 1, but we don't know what the square root of 2 is. If we were to rationalize top and bottom by rationalizing the bottom by multiplying the top and bottom by root 2, we end up with plus or minus root 2 over 2, and this is a value that we do see on the unit circle. So let's draw where these different values appear. So sine x equals root 3 over 2 at 2 spots. These are the tall triangles that will be in quadrants 1 and quadrants 2. These angles are at pi over 3 and 2 pi over 3. For cosine x equals to plus or minus root 2 over 2, you should know that root 2 over 2 always happens at the 45s. So here are the two angles where cosine is positive. So pi over 4 and 7 pi over 4. And then here are the two angles where cosine x would be negative root 2 over 2. And those would be at 3 pi over 4 and 5 pi over 4. So this problem has 6 answers. 1, 2, 3, 4, 5, 6. All right, almost done. Number 19. So we've got 2 sine squared x equals 1. We'll divide both sides by 2, giving us sine squared x equals a half. Then if we square root both sides, we'll get sine x equals, hopefully this won't be too much of a jump, plus or minus root 2 over 2. It's the same as what happened in number 18. If you square root a half, you get root 2 over 2. And don't forget, when you square root both sides, you should get plus or minus. All right, so when does this happen? Well, it turns out that this happens at the exact same place that cosine x equals plus or minus root 2 over 2. Here are the two spots where sine x equals plus root 2 over 2. That would be pi over 4 and 3 pi over 4. And here are the two spots where sine x equals negative root 2 over 2 at 5 pi over 4 and 7 pi over 4. So this problem has 4 answers. 1, 2, 3, and 4. Okay, so we only have one more problem to do, number 20. So number 20, we've got 4 10x equals 5 10x plus root 3. So I'm going to subtract 4 10x from both sides, leaving me with 1 10x on the right side, and I'm going to subtract this root 3 to the left side. So now you just need to know, when does tangent of x equal negative root 3? Well, these would be the tall triangles, the pi over 3's, but it's negative in quadrants 4 and quadrants 2. So between 0 and 2 pi, there are going to be two answers. One of them is going to be 2 pi over 3, and the other is 5 pi over 3. So those are our two answers to this problem. And that's the last question.